So I've had you guys working kind of like a pop quiz on the system of equations that you see. I'm going to go ahead and go through the steps, making sure that you guys have the first column. I've been walking around the room trying to help some of you that I saw were totally stuck. In our first column, what's the very first thing we want to get or establish? The very first thing is the 1. The very first thing is the 1. But lucky for us, the 1 was already in the right spot, right? Because remember, the goal is to end up with the identity matrix with a leading diagonal of 1s, 0s everywhere else, and numbers representing the x, the y, and the z. Okay? That's our end goal. That's our end game. So the very first column, I want 1. Okay, well, he's fine. And then followed by, in the next 2 spots of the column, 0, 0. Now, in order to get zeros in our notes, we talked about how we need to add to cancel out. To add to cancel out. And if you guys were looking in your notes, hopefully you saw that whenever we went to go get zeros, we would actually say, first of all, this first row is perfect the way he is for that first column. So we're going to keep him because the 1 is good in that first column. But the second row, third row need to be canceled out. Who's in the second row? That spot? First column? I need it to cancel. So I'm going to go ahead and get the opposite of that. Because if I could get negative 3 plus 3, I could cancel them out. So we take whatever or wherever the 1 is and say multiply wherever the 1 is, which is row 1 right now. Multiply it by the opposite, which is negative 3, and then what, guys? Add it to row 2. Because if I take this, multiply by negative 3, and add, boom, I have my 0. However, when I'm doing like systems of equations, which is ultimately the math we're doing just in a nice numeric, concise way, can I ever just add 1 or 2 of the pieces together but not the rest? No. So I have to repeat the operation to everybody. So negative 3 times negative 3 is positive 9 minus 1, 8. Negative 3 times 1 is negative 3 minus 1 is negative 4. Now some of you, you're like, you're losing me. It's too much mental math. So remember, you can always take row 1 and say, hey, I need negative 3 times u. And actually do that. Negative 3, positive 9, negative 3, negative 6. Multiply every single term by negative 3. Row 2, I just need him to stay the same. Okay, no big deal. Keep him the same. 3, negative 1, negative 1, negative 6. I need to add those 2. You can do the math off to the side if you need to. We end up with 0, 8, negative 4, like we were doing over there. And what's our last one? It should have been a negative 12. You guys tracking? Now, I'm not good until I finish off this column and get another row. So I have 1 0. Let's get another. Remember, the system says take the first row, aka the location of the 1, multiply it by the opposite. Well, what's the opposite of this guy? Oh, hey, look, this is just happens to be, you could just add the 2 together, right? Because 1 plus negative, 1 plus negative 1 would be 0. So even though I am going to say take the opposite, which is positive 1, multiply it by row 1, add it to row 3, the system works too, but we could have just added the 2 together. And some of you, like in period 2, some people were like, well, just add the 2 together at 0. And it's like, yeah, exactly, that's perfectly fine. But could we have added 1 plus 3 together for row 2? No. I needed to multiply by the opposite because otherwise I wouldn't have gotten my 0. This one, it is as simple as adding together, so we just add together every single piece. So what did you guys get for the second term, those of you that got here? Negative 2. How about for the third term? Good. And then the last term? Perfect. Is our column 1 good? You're 1/3 of the way done. We just got to repeat the second column and then the third column. So, second column. Hold on. Wait. We always start by getting the, okay, but pause. Where is the 1 supposed to be in the identity matrix second column? In the middle. Yeah, good. Second row. So right now there's an 8. That's no good, right? Okay, good. We need to get that 8. Well, if you want, you could, and actually you should, say we can't deal with rows 1 or 3 right now. We need to get the 1 first. So we're actually going to rewrite row 1 and row 3 to start off and say we can't get the zeros yet. We need to get the 1 first. So we rewrite row 1 and row 3 and say, okay, we're dealing with row 2. He's the guy we got to choose or work with or change. I need a 1 in the 8th spot. In your notes, when we said getting a 1, it wasn't adding or subtracting. Because if we started adding or subtracting, we might end up messing up the 0. The only way to always maintain the 0 while getting a 1 is just to divide or multiply by the reciprocal. Same thing. So dividing by 8 is like multiplying by 1 over 8. You guys might have noticed I've left off the arrows because the arrows just say put it here, put it here. All right. We can simplify the notation just a little bit. So I'm writing it in the row 2 row saying, hey, take row 2 and multiply by 1/8. So guys, what's 0 times 1/8? Exactly. The 0 stays where I want them to be. What's 8 times 1/8? Or 8 divided by 8? Negative 4 divided by 8? You would reduce the fraction to negative 1/2. And negative 12 divided by 8? Good. Negative and then 3 over 2 is what that fraction would reduce to. Are we okay with how I got the 1? Circle the 1 and say, ha-ha, the 1's established. You don't have to say ha-ha, but the 1's established. What did we do up above when in column 1 the 1 was established? We left it like that, so we rewrote that row and said, hey, he's good now. But then didn't we have to work with the other two? And our objective was to get the zeros. Let me give you guys a little bit of time to try to keep going. First of all, those of you who are totally done, can I see hands real quick who are like, I think I have an answer? Perfect. Can you guys go ahead and get out your calculators and double check that you're right? Get out your calculator, double check that you're right using the RREF feature. And once you double check that you're right, I want you to locate someone in your group first of all, if there is someone who's not done yet, and be like, hey, what can I help with? Okay? So people who are totally done, checking your calculators, you're just practicing real quick that you still know how to use the RREF feature. Make sure that your answer is right. If not, then you're going to have to go back and find a mistake, right? But if your answer is right, golden. You can explain to someone in your group who's not done yet. And actually in period 2, people started walking around the room and just helping friends and other people too. So if you have it right, awesome. People can learn from you. They're still checking their answers. I'm not sure they're done yet. But you know what to do. You have to make your little formula to get the 0, right? By adding. So look at what's there. Column. We're going to do both of them at the same time. Because this guy needs to cancel out a negative 3. This guy needs to cancel out a negative 2. So they're going to need 2 different little formulas to cancel each one out. With row 2. Yeah. So this time we're multiplying by the 1 in row 2. So last time we were multiplying by the 1 in row 1. Now, hold on. If we do 1 row 2, is that going to cancel with anybody? 1 times 1? Okay. So not 1 times row 2, but what times? But negative 1 isn't going to cancel with either of those either. Look at this number. I need a positive 3 times row 2 plus row 1. Does that make sense? I need the opposite. Plus row 1. Does that make sense? Now see what happens when you do that. And you can write it out again, totally fine. If somebody has a formula for the first row and has worked it out and think they have it, oh, let me see. Let me see the formula. What'd you do? I love it, except if you do negative 3, it's going to be negative 3 plus, got it, positive 3. Got it, Aiden. So then go ahead and work that out. Okay, one of my guys that's checked it and you're right. Go on up and show me the first row and the third row. Who has it right? Come on, I know. Rachel, you do perfect. Can you show me what to do next for row 1 and row 3? Thanks, girl. Okay, well. Oh, let me see. How do you write it? I'm just curious. looks the same though, except your numbers are different. Oh, did you switch them? Did you switch? 1 negative 3, 1, 2. 3 negative 1, 1 negative 6, negative 1, 1, 2. Oh, you're not following the system. You're making your own. Okay. It's working, Rachel. You're right. It's just not going to be the system way.
Let me check it. I don't have a calculator. Oh, just ignore all this.
It could be right, but you have to keep going. So get me 2 zeros, and then see what happens. Get all the way. Get 2 zeros there. Oh, the same way you did before. How'd you get zeros here?
I divided, but if you divide this, this will change. These two will change.
Oh, you don't want to divide to get zeros.
If you plus the opposite, this will go here.
Ah, but hold on. If it's by this, 1/2 plus 1/2, 0, 1/2, 1. Aha! There you go. Wait, is anybody following the system like I've taught them and can fill in row 1, row 3? Oh, Caitlin, get up here. I was going to say, I'm surprised this class, if I could get period 2 people to do it, you guys should be able to do it. All right, watch what she does. There's a negative 3 and a negative 2 that she has to get rid of. Hold on. I just have to not stop writing. Yes, that's the struggle. Oh.
Wait, this is after the 1. Oh, okay.
Okay, it's pretty close right now. There you go, you got it. Why did she put a positive 3? There was a negative 3 there, so she do the opposite. My mental math, check that you got it right. My non-mental math, you could have written it off to the side. Why is she doing positive 2R2? There was a negative 2 in R3. Huh? I think it's good. Let me see your work. So you need to take 8 and then add it to that guy. So 3 times that would be 0, 3. It was a negative. And you didn't keep it negative. Well, that was a good thing, actually. But here was your... You could multiply him by 3. Yeah. You would have wanted a negative. So instead of doing 3 plus 2 is 5, you gotta do negative 3 plus 2, which would be negative 4. You see it? There you go. Yeah, it was just the negative sign. Nice. All right. So Caitlin did 2 steps. First of all, she finished column 2 by getting rid of the 3 and the negative 3 and the negative 2 that were there to begin with. Why did she multiply by row 2 when we were multiplying by row 1 up above? Because we were getting the zeros in row 1 and 3. Who was staying the same? The 1 in row 2. So she took where the established 1 was. She multiplied that by the opposite coefficient for each of the respective rows. So she used where the 1 was as her foundation for who to multiply by and then who to add to the rows that she was changing. Any questions on how to get column 2? Did we get there? Okay. Then she went one more step. What was she doing in this step? Moving on to column 3 and getting the 1. And what was there to begin with? So what did she do? Divided or multiplied by the reciprocal. Now, this is technically in row echelon form. If you were to do this and to stop here, we would still have to back substitute and write 1x minus 1/2 z equals, and 1y minus 1/2 z equals, and z equals, and plug in and solve. But remember, our objective is not to stop. This is our REF, reduced row echelon form. Our objective is to keep going until we have this full identity matrix with, those look like dollar signs. They're supposed to be number signs. Anyway, long story short, go all the way. So guys, what's left to do? Get the zeros. Yeah? So let's work together on getting the zeros. Wait, which one is allowed to stay? Who's good? Good. He's fine, right? 0, 0, 1. He's good as is. You would have had to look up above and say who was in that spot? A -3. What did she need to be there? A 1. So multiply by the reciprocal. So every single time when we want to get 1s, always multiply by the reciprocal. Okay. So we're getting zeros now. Are we multiplying or are we adding to get zeros? Adding. But we need to add to -1/2 to get 0. So don't we need to add positive 1/2? Calm down, Jack. Okay, here we go. -1/2, we want to add 1/2 to get 0, to cancel out. So how do we get a positive 1/2? Well, guys, hold on, wait a minute. Who's established? Row 3. So let's go ahead and multiply row 3 by the number that I need to cancel this out with, which would be 1/2, right? And who am I adding it to? Well, right now, what row am I in? Okay, so I'm adding it to row 1. And then row 2 has the exact same problem, a -1/2. So use the row with the established 1, row 3, multiply him by the opposite 1/2, and then add. Let me give you guys a couple seconds to finish this off if you have not yet. Remember my non-mental mathers. It's totally fine, no shame in actually doing the math off to the side, like multiplying row 3 by 1/2, which would be 0, 0, 1/2, and then 1/2. And then going ahead and adding that to whoever you need. For instance, the first one would be row 1. My mental mathers, hopefully you were doing this correctly. That'd be -4/2, which is the same thing as negative. Do you guys get -2? My non-mental mathers, I won't show the next step. You would just take the exact same 1/2 times row 3 and add it to row 2. And you'll end up with 0, 1, 0. Have 1/2 minus 3/2, which will be -2/2, which is -1. Final solution. My people in my calculators that checked. Did it check out? Yeah. -2, -1, +1. Can you do it? The answer should be yes. Is there a system, a method to the madness? Is there a method to what we're doing? Yeah. Are we working by columns? Mm-hmm. Do we have a goal in mind as to what we're trying to get? When we're in a column, do we always start with the same objective? Get the wherever it needs to be. So we're in different rows at times, but we're still getting a 1, and we always get a 1 by multiplying by the reciprocal. Once we establish the 1, then what is our goal? In each column, whatever one we're in, get the zeros. And every time we get the zeros, adding, after multiplying the row with the 1 by the opposite. Multiply by the opposite and add. This is how you would do RREF, reduced row echelon form, Gauss-Jordan elimination. And just a quick heads up, thinking towards the test, you're like, we're in section 8.1. Thinking towards the test on this chapter, the by hand portion, no calculator, only get full credit if you follow the directions and solve the way I ask you to. This is probably the hardest in this entire chapter by hand type of problem to do. That's not bad. We just, it's possible, right? Just got to be careful. But it's possible. This is probably the hardest by hand problem of the chapter. Type of problem. By hand for the chapter. Okay? I want to take a little bit more time so that you guys could see whether or not, and hopefully be convinced that you can do it. It's not this crazy, outlandish, huge, super complicated process that's changing all the time. It's not. You're going from a system to the identity, going column by column, tackling one thing at a time. And as long as you follow the system, you will always end up where you need to be, as long as there is a nice solution possible. On the test, if I ask you to do it by hand, there will be a nice solution possible. But yesterday in our notes, are you guys still in your notes? Weren't there some weird ones that we didn't get to finish talking about? We started, we just didn't get to finish. If you guys have your calculators, or even if you don't, we don't have too much time, but this is where we got behind period 2 yesterday. So we have a little extra time from them. They actually took all the way to the end of the period in the last one, but they also hopefully saw that every one of them, even those who were totally lost and didn't even know how to make a matrix at the beginning of class, hopefully can see that they know how to do it, or they can do it too. Guys, what was weird about 71? Now, I copy and pasted stuff in because I lost all of period 2's notes yesterday, so I put it in yours and copied into theirs. What's weird about this guy? Inputting into your calculator, or even just solving by hand. There are no z's. So what did I have you do in your calculator to account for that, or to make up for it? Put a 0 column where the z's should be. Your calculator, if you did RREF to this matrix, RREF to this guy, bad or weird? What's going on over here? Okay, 1x equals 0. That's okay. 1, 1 equals 0. That's okay. X plus 0, y plus 0, z equals 1? How can 0 equal 1? It can't. It's a false statement. There's no solution possible for this system. Does that make sense? There's no solution because of the false statement. What's different in this example? What's missing? The third equation. So what did I do in my matrix when I went to my calculator? I put in a 0 row. Do you guys see how the z column was missing? Put in zeros. The third equation is missing. Put in zeros. What does my calculator tell me when I run RREF? It tells me I don't know what to do, right? It does as much RREF as it can. Well, you didn't give me enough. So then this column is off the whack. It's still in RREF form. It's like, this is as far as I can go. This is RREF, the best I can give it to you. It's the best you could have done by hand. Now, I could rewrite this as x minus 5z equals 9, which I did, and y plus 9z equals 1, which I did. But what's going on down here? Guys, what do we always do when we have a true statement which indicates infinitely many answers, but I still need to express how they relate? Let z equal a. It comes back. If it's an impossible, or if it has infinitely many solutions, if the calculator ever does this for RREF, there are solutions. Please don't forget that. It's not false, it's true. 0 equals 0, sure. But you have to let z equal a, and then plug in to finish solving. You guys know what I mean by plugging, substituting. And then you would finish solving. So the final solution to this one, since we have just a little bit of time, would end up being x minus 5a equals 9. So x would equal 9 minus 5a when you plug in. Y would equal 1 minus 9 times a. And z would equal a. So there are some weird ones that can show up in section 8.1 homework. It's the homework we were supposed to grade at the beginning of class, but some of you were not convinced that you personally could do a problem like we just did. Hopefully you see you can. So tomorrow, first things first, we're going to grade 8.1 real fast. Then we're going to try to do all of 8-2 after that tomorrow, because then 8-2 is due on Friday. Yeah.
Wouldn't x equal 9 plus 5 since the next one?
Oh, I failed. Thanks, Blair. Did anybody else figure out that it was a plus? Corrections you were supposed to turn in at the beginning of class. If you haven't yet, you still have time. Staple, the staple is at the front. Staple on top of the test. Go put in your folder in the back. Yeah, by the end of the day. That's okay. All right, anybody else with test corrections? Ready to go. Go turn them in. Otherwise, end of the day. And you guys have 20 seconds until you can leave.